Okay guys, so today we're going to talk about prime numbers and why 1 is not a prime number. So here's the story. So one day there was a 1 and he was with all of his friends and then he was like, hey guys, can I be prime too? And then 3 was like, you are not prime. And then 5 was like, yeah, you are your only factor. And then 7 was like, yeah, 1 is your only factor. Okay, so for us to know why 1 can't be prime, we have to look at the definition. And the definition says a prime number is a whole number whose only two factors are 1 and itself. But a very important part of the definition is that they have to be whole numbers greater than 1. So the definition says that it doesn't include 1 as a prime number. So also for all you grammar snobs out there, we can see that the definition has the word 1 in it. So obviously we need a better reason for why 1 can't be prime. So let's just go ahead and consider the case where 1 is prime. If 1 was prime, then nothing else could possibly be prime. And that's going to make all the other prime numbers like 3 and 5 and 7 very, very, very angry. And as you can see here, they are screaming madness, and they are very upset and very distraught. So now we're going to look at a little bit more of a proof. We're going to say, let's say that 1 is prime. This makes 1 happy. Then 1 has two factors. Well, 1 and 1. But then I guess it could have 1 and 1 and 1 and 1. But then each of those ones is going to have two factors, and it's just going to go on forever and ever and ever and ever. And that is blasphemy. So mathematicians needed a way to avoid all of this madness. So what they did, just like in many other cases, is they made a rule that just said that it couldn't be so. That rule is called the unique factorization theorem, or is also known as the fundamental theorem of arithmetic. This theorem is obviously super important because it's called the fundamental theorem and it's over all of math. This theorem makes prime numbers super happy because they know that they're important and that they're needed and that there is value found in prime numbers. And that basically all of math depends on these prime numbers and this theorem. So the fundamental theorem of arithmetic says that every number can be factored down into just prime factors. For example, 25 is factored to 5 and 5, which are both prime. 27 is factored into 3 and 9, which 9 can then factor into 3 and 3, which are both prime. And then 12 is factored into 3 and 4, which factors into 2 and 2. So these are all prime. But what if 1 was prime? Then you see that all of these factors are then going to be factored more into 1 and 1 and 1. And then it's not unique anymore. You have so many different ways to factor numbers. So mathematicians had to make a choice. So way back in the old days, there were some dudes just talking about math, and they decided that 1 just could not be prime. He could not be in the club with all the other prime numbers. And then, of course, they decided they must base all of math on this. So evidently, 1 was very upset. He was crying, he was sad, he was heartbroken because he really wanted to be in the club. But this made all of the prime numbers much happier, and it made all of the old mathematicians a lot more content with their choices. So let's talk about the unique factorization theorem again and get back to why it is so important. One of the most important parts of it is that it is unique. That means there's only one way to do it. So what happens if we let 1 come in is that then it's not unique anymore, because then you have an infinite amount of ways to describe a number. So even though 1 is going to beg and plead and just really wants to be a prime number, it just can't be. Take the example where we factor 30 into 2 and 3 and 5. But then if you let 1 be a prime number, you're going to notice that then you've got multiple ways to factor that number. You've got 2, 3, and 5, 2, 3, and 5, and 1, 2, 3, and 5, and 1, and 1, and 2, 3, and 5, and 1, and 1, and 1, and 1, and 1, and it's just going to go on forever. You can see that this makes all of the other prime numbers really upset because we need the unique factorization theorem, and this breaks that rule. The unique factorization theorem is so important because it gives us these awesome things like the canonical representation of numbers, which is a specific way to describe every counting number that we have. It also gives us all of our operations. So adding and subtracting whole numbers is how we get all of our counting numbers, and then multiplying and dividing by 1 leaves us with the same number, which is a very important fact for math. So we can see that math needs 1, we just need it to not be prime. 1 is super important for math, and it has all of these awesome, cool properties. They just aren't the properties of a prime number. So 1 and all of the prime numbers can live in harmony, and they can all be happy for each other because they're all different and they all have their own special qualities. So then all of the numbers supported each other through all of their differences and their special traits, and then they lived happily ever after, and we have a perfect system of math.